So in this problem set, we're going to look at linear equations, word problems, and in these cases here, we don't have those graphics that have helped us before. Okay, so we do need to understand it from the perspective of the equation, not just looking at the graph. So looking at this here, we have we'll be given an equation generally, or we'll be given something that will allow us to build an equation, and we can use that equation by plugging in a value for the x, if this is y equals mx plus b, or f of x equals mx plus b, and so on. We'll be able to plug in a value, an input value, to get the output value based on the function. So in this case here, Harry took a loan from the bank. D of t, the function d operated on t, models Harry's remaining debt in dollars as a function of time. So the function is based on time, okay, and the remaining debt is dependent on how much time passes. So here's your function right here. Our d of t is equal to negative 200t plus $9,000. Now what this function here means is that, and it helps to look at this, it helps to look at it from the perspective of, well, what does this mean over time, right? What we're talking about here is we're talking about a repayment of $200 per month. So you're talking about a repayment of $200 per month, right? So at 0 months, there is no repayment on a loan of $9,000. Okay, that's what we're looking at here. So at month 0, so when Harry got the loan to begin with, at month 0, he still owes $9,000. Well, let's look what happens at month 1. So now he makes one repayment. He makes the first month's repayment, and what we see here is he's paying back $200. And that's being multiplied times 1 because it's the first month, and we add on the y-intercept, which is the initial value of the loan, and we find that this is 9,000 minus 200. So he now owes 8,800. Okay, so it does help to understand what's going on here. Month 2 comes along. And in month 2, he's paying back another $200. Now, because we're measuring this in month 2, we're kind of discounting what month we did. We're ignoring what happened in month 1. Now we see he's actually paid back $400 total, which is negative 200 times 2, which is 400. We add on the initial value of the loan, and that's 9,000 minus 400 is 8,600. So we see here what is happening over the course of the loan. So this is how the function works. We're plugging in each value. That's not quite what the question is asking us, but it helps to understand this process. So reading the equation here, we see that the initial value of the loan was 9,000 and the repayment was $200 every month. Now it does say negative 200. The equation needs the negative in order to subtract from the initial value, but what he's actually paying back is 200. So we've got to look at a bit of what we call absolute value there. More on that later. Looking at another question here, we've got Agent Hunt is transferring classified files from the CIA mainframe into his flash drive. I'm sure that's illegal, but, well, he's doing it. S of t, so the function s operated on t, models the size of the files on the drive in megabytes after t seconds. So again, t over time, the size is s. So the function s operated on t gives him the amount of data he stores every second. So here's our function right here. Over time, the amount of size of the files on the drive. So the amount of size of the files on the drive after t seconds, this is telling us here that he started with 45 megabytes already stored on the drive. Every 5 seconds, he's adding on, or every second, he's adding on 5 more megabytes. Okay, so we're being asked here now. We're being asked something different. We're being asked for what happens for how many megabytes are transferred every 10 seconds. So we're not quite looking at the entire equation. We're being asked how many megabytes are transferred every 10 seconds, which is a slightly different question. Not how many megabytes are on the drive after 10 seconds, and how many megabytes are transferred. So we're only looking at this part of the equation. So what we need to do here is 10 seconds multiplied by 5 gives us 50 megabytes. Okay. I hope that's enough to go by. As I've said before, these questions not over the top challenging, but it does help to read through the question, understand exactly what the question is asking you, especially with a question such as this where you might have added on the 45 at the end. Be careful. It's how many are being transferred, not how many, what is the total size of files on the drive. So you will need to break down some of the equations into separate parts to understand this. Okay, good luck.